A block with mass m1 equal 4 kg and a ball with mass m2 equal 7 kg are connected by a light string that passes over a massless frictionless pulley as shown in figure 4.39a. The coefficient of kinetic friction between the block and the surface is 0.300. Find the acceleration of the two objects and the tension in the string. B. Check the answer for acceleration by using a system approach.
Okay, so the word is second part is system approach. Okay, the meaning of system approach is you are
Hmm.
going to look at the system as a whole. For the first part of the question, we are considering the objects one at a time. That is, let's say we consider the 4 kilogram mass and the 7 kilogram mass. We look at them individually. But for the second part, we are going to look at the system as a whole. Okay, so I hide this first. I hide this. What are they? Hide this. Hide this. Okay, so we're going to look at the first, although there are two objects connected together. So the first one we are going to look at is this 4 kilogram mass alone to form the equation. Then we are going to look at the 7 kilogram mass alone to form the equation. Okay, right. Okay. So now we are going to look at the 4 kilogram mass, the one that is resting on the table. Now, this 4 kilogram mass, it is drawn separately over here. Okay, drawn separately over here. Here, right? It's drawn separately over here. Instead of looking at it on the table, you're going to look at it like this through a force diagram. The forces acting on the 4 kilogram mass, they are the weight of the object, which is mg, the normal reaction, which is n, the tension in the rope pulling the object, and also the friction that is going against the motion of the object. So there are four forces. Since the numbers are given, so we're going to draw another diagram with numbers there, right? So this is the object, 4 kilogram mass. Okay, the weight of the object is mg, but we know that the m is 4 kg. So the weight is 4g, this one, the weight is 4g. And the normal reaction is n. And this normal reaction and the weight of the object, they are the same, right? Okay, next we are going to look at the horizontal forces. There are two horizontal forces acting on this 4 kilogram mass. The first one is the tension that is pulling the object towards the right. The other one is the frictional force. Actually, it's mu n, the coefficient of friction multiplied with the normal reaction. In this case, the coefficient of friction is 0.3 and the normal reaction is 4g, which is equal to the weight. So this is the frictional force and this is the tension. So these two forces, which one is bigger, right? So the acceleration will be in the direction of the bigger force, or maybe I say the net force, right, will be together with this. See who is bigger, right? You remember in our last lesson we said the one bigger minus the one smaller is the net force, right? Okay, so first one, normal reaction, we call it n. The tension in the string or the rope, we call it T. the weight of the object is mg. In this case, it is 4g because the mass is 4 kilogram. Okay, next, the kinetic friction, okay, it is equals to mu n, the coefficient of friction multiplied with the normal reaction. And because the tension is bigger than the friction, so there will be a net force, and this net force will cause the acceleration. Okay, and you can look at this diagram here, and you know that one force is bigger than the other, and it will produce a net force. The net force will produce acceleration. Okay, so connecting the vertical and horizontal forces, the normal reaction N is equals to 4g. Okay, the first one, considering the vertical component of the forces. The second one is the net force. The net force is the bigger force minus the smaller one. Okay, so the net force is the tension minus the frictional force. Okay, so the net force is equals to T minus the frictional force, which is the kinetic friction. The kinetic friction. That's why it is denoted by a small k at the bottom. And according to Newton's second law, the net force is ma. So I'm going to replace the T. We still copy it as T, but the frictional force you replace with mu n. Mu is the coefficient of friction, 0.3, and n is the normal reaction, which is 4g. Okay, so we have one equation here, and we're going to make the T the subject of the formula. So the tension in the string is, the mass is replaced by 4. The mass is replaced by 4. So it's 4a plus this multiplied together is 1.2g. So this is the first equation we obtain by considering the 4 kilogram mass. This 4 kilogram mass. Okay. Now, we just look at the 4 kilogram alone, right? We look at 4 kilogram alone. So the mass here will be the 4 kilogram mass. The m here will be 4. Right. So we are going to look at the second object. The second object is the round ball, the ball here. So we copy this ball and put it separately. There are two forces acting on this 7 kilogram mass. The first one is the weight, which is equals to mg, and the second force is T, the tension in the string or the rope. Now, of these two forces, the mass and the tension, one will be bigger than the other. So when one is bigger than the other, there will be a net force. The net force will cause this object to accelerate in a certain direction. That direction is in the direction of the bigger force, right? So I change this m to 7. So the weight is actually 7g, because the mass is 7 kilogram, is 7g. Okay, right. So the two forces, they are the tension in the string and also the mass of the object. As a result of these two forces, there is a net force that will cause this object to accelerate. So we say that the net force equals to the bigger one, the bigger force, 7g minus the tension in the string. To know which one is the bigger force, you see where the object is moving. The object is moving in the direction of the bigger force. Okay, the direction is moving downward. That means the downward force is bigger than the upward force. So to find the net force, we use the bigger one, which is 7g minus the t. Earlier on, the object is moving along the table from left to right. So we know that the left force, the tension must be bigger than the frictional force. Otherwise, it won't be moving in the towards the right. In the second object, it is moving downwards. So we say that the 7g is bigger than the t. So we use 7g minus t, and that will be the net force. 7g minus t. And we also know that the net force is mass times acceleration, according to Newton's second law. And in this case, since we are considering the 7 kilogram mass, the m here must be 7. So 7a is equals to 7g minus t. And we make the t the subject of the formula. So t is equals to 7g minus 7a. So this one, we call it the second equation. So by solving the second equation with the first equation, simultaneously, we can find the value of a and t. Now, how to solve these two equations simultaneously? We're going to equate them. Since this is equals to t, and this one also equals to t, we equate the two of them. So 7g minus 7a is 4a plus 1.2g. So we say that 11a equals to 5.8g. So what is the value of a? A is 5.8g divided by 11. So if you use your calculator, 5.8 times 9.8 divided by 11, you will get the acceleration 5.17 meter per second square. Substituting the acceleration back into equation 2 here. Okay, let me draw it out. So this value of a, 5.17, we substitute back into this equation, the a here. So it's 7g minus 7, a is 5.17. So using your calculator, you get the tension is 332.4 Newton. Okay. They say check your answer for the acceleration by using the system approach. What is the meaning of system approach? System approach means you look at the system as a whole. You look at the diagram on the right. When you look at the system as a whole, the tension in the string will cancel each other. You see, earlier on we have tension in the string, we have tension in the string here. Right? But if you look at the system as a whole, the forces that is acting on the system, they are the 7 kilogram mass, which is pulling it down, and the frictional force, which is opposing the motion. Okay, and which direction is the system moving? The system is moving clockwise. Okay, the A is here. So if the system is moving clockwise, is moving downwards here, so the 7G, the weight 7G must be bigger than the frictional force. Okay, so there are only two forces acting on the system. The tension, they are the internal forces, they will cancel one another. Okay, so since the 7G is bigger, because it is moving in the direction of 7G, so the Newton's second law will be the net force is 7G minus the kinetic friction. 7G minus the kinetic friction. Okay. Okay. So when we look at the system as a whole, the mass times acceleration, the mass, we cannot say it is the mass of the 7 kilogram, nor the mass of the 4 kilogram. Okay, if you are looking at the system as a whole, the mass also you have to take the system as a whole, which is 7 kilogram plus the 4 kilogram. Okay, so if you look at the equation, net force is 7G minus the kinetic friction. Net force is MA, and 7G is the weight of the object, and mu n is the frictional force. As I've said earlier, if you look at the system as a whole, the mass is not 7 nor 4, but it is 11. The whole system, the mass is 11. So mass times acceleration is 7G minus mu m. Mu is 0.3, n is 4G. So we have 11A equals to 0.8G. So A again is 5.8G divided by 11. You see here and over here, both of them, they have the same value for A. So if they ask us to check the answer for the acceleration using the system, the answer is correct. Both of them, they are same. So whether you are looking at the system as a whole or you are looking at the individual object, the acceleration is consistent, right? So both looking at the objects individually, you will get the acceleration. If you look at the system as a whole, you will also get the same acceleration. So it is consistent. Any questions so far?